So before we start anything, we need to present you because Dr. Mohsen is a great expert with great achievements. And we cannot talk about digital transformation without talking about data, because data are the seeds, data. Everything is about data. And digital transformation is technology side, data side, and that's why we invited him. He's more than a data scientist. Yeah, if you say data scientist, then we are underestimating Dr. Mohsen, okay? Dr. Mohsen has great experience. He has been working in different universities all over the world. And I'm so happy that you made the time that you can share with us today. But for everyone again, the recording will be uploaded on our YouTube channel, which you need to subscribe to our YouTube channel. And we will take permission from the doctor. Just few things we will share on YouTube channel shortly. So doctor, before you start with the presentation, please introduce yourself to everyone in the room, please.
Okay, my name is Mohsen Farid. I was actually born in Egypt, so I am Egyptian, and I'm very proud to be an Egyptian. But I also lived in America, where I had my first doctoral degree in theoretical physics. And then I was teaching at the universities, a number of universities there. I then joined IBM, and I was a senior scientist at IBM, working on the large Unix establishment in there. And then over the past now almost 15 years or 20 years, I went to England, and I got another doctorate degree in computer science, specifically in data science. I have been doing consulting as well as being a professor at the university, having PhD students, but also I have projects now in the retail business with Walmart, the American chain, as you probably, a good number of you might know it. Also, I have projects in the stock market in London Exchange. I also have applications in healthcare and medicine. So I think when it comes to talking about data, alhamdulillah, I feel very comfortable because I have done both research and applications across the board. Today, first of all, I would like to thank Dr. Shireen for inviting me to this. I'm very, very excited to share a bit of my knowledge with my colleagues and students and friends. It is a subject that I feel very, very strongly about because in today's age, data analytics sits in the middle of the revolution, which we call digital transformation and Industry 4.0. So as such, what we see is when we talk about digital transformation, it did not happen actually today or last year or the past 10 years. It's been actually building over time, even before the internet in the 1990s. I remember when I was doing my master's degree in Cairo, I was actually working on systems that really led to where we are today. So digital transformation is the key strategic initiative to describe the implementation of new technologies, and also includes the talents, the processes to improve business operations and satisfy the customer. So basically what we need here is there are two objectives here. One is how to make their business successful, and number two is how to make the customer happy, and we measure the success of the company by how happy the customer is. So as you see, when you go to something like Amazon, for example, after you purchase something, there are 5 stars there, and it basically you say how much you are satisfied with the service that you got by the number of stars that you give. You can give 1, you can give 0, you can give 5, and then they do some basic statistics to show you where your opinion is on the scale of things. So this is one application of the digital transformation in terms of retail. Walmart and Bed Bath and Beyond during during COVID actually were able to provide deliveries of products to individuals, customers, by not having the customers visit their shops, but rather they go and stay at the curb or receive, and they will deliver. So all this was done using what we might call the digital transformation applications. So now in big organizations like the European Commission, for example, which we all know a lot about, they say that data is the new gold. You remember there is the traditional gold that people wear, the yellow gold, and then we call petroleum to the black gold and cotton as the white gold. So now data is the new gold that we need to speak with. The consulting firm or institute, McKinsey's, basically says big data is the next frontier for opportunity, for innovation, competitiveness, and productivity. So this is what digital transformation really means to all of us. So here, if you look at it's the innovation, opportunity, market leadership, and at the end, happy customer. This is how we measure our success. So where does that data come from, or data come from? It comes from databases. Any business today they will be able to manage their day-to-day processes, transactions using databases. Banks will have databases. If you go to a supermarket, they still have a database. It might not be as complex as a bank, but it is a database. Financial transactions in banking, the stocks, every second there are different prices for the different stocks that you have. Commercial activities, product specs. When you design a product and you want to keep the product specifications, you basically put it somewhere where you can easily access it, and it becomes part of the process pipeline. Of course, social, in terms of getting the benefits like a retirement, or also social networks where we talk with one another using Facebook or WhatsApp, or even something like Zoom here. Industrial products, sensors is very important. And when we talk about the industrial revolution, especially when it comes to manufacturing, mechanical engineering, petroleum, things of this sort, we talk about IoT, the sensors, the Internet of Things, which are devices that are able to communicate with one another, so that the information comes from maybe some sort of a meter all the way down to the engineer, where they are actually analyzing whether there is an increased production of oil, for example, or it has gone lower, or just to be able to control that. As you know, medical, every one of us has gone to a hospital and they measured our blood cells. So there are and imaging labs, clinics. Education also uses data analytics. They have to collect data. Of course, sales, as I mentioned, you have Amazon, you have Walmart. And this morning I was heard about a young man actually working, studying in actuarial science and insurance. So how do insurance companies actually tell us how much we have to pay for the car, and all the information about ourselves and about the car that we have. So collecting all that allows us to make the right decision so that it goes into the product that we are trying to develop as a company. Okay, so we have collected the data. What do we do with the data? The data has basically three levels. One is the raw data that you collect from the field, from the supermarket, from the hospital. And then you combine that into some kind of information. So you would be able to make a sentence to describe what you have done with this data or what has happened in the process that generated the data. And then at the end of the day, when we talk about the chief executive officer of the company, the general manager, wanting to take the company, changing their direction or making a huge step in how they present the products, that is what's called the storytelling or the wisdom that the CEO provides or his C-level staff. So, these are the three different levels. This is done, the data is done at the engineering level, information is done by a middle management, and the storytelling and the wisdom is at the top management, the executive, the C-level folks. So what we see here is that we collect huge amount of data, which we call big data. Now, there is no, what's happening here, if you have a sensor, if you are having a counter, let's say at one supermarket, small supermarket, where it is working all day from 6 o'clock in the morning all the way to 12 midnight, you are collecting data. So this is big data. Of course, the word that describes big is extremely relative. So if you go, for example, at CERN, where they actually they break the protons and the systems that make up the universe, they will generate terabytes of information on a daily basis. While, you know, a small supermarket next door to my house probably will do maybe 10 megabytes of data on a daily basis. So the word big here is relative depending on the establishment that is collecting. And you can use that to be processed by high performance computing. Of course, you also need this to store it, and maybe you need some sort of a grid, meaning a bunch of computers connected by a network. And of course, the algorithms that need to process this data need to be also developed. But there are three main objectives here, and they call it the 3V, which is the volume, the velocity, and the variety. The volume is how much information you're getting, collecting per unit time, maybe per day, per week, per month, per year. And then we talk about the velocity. The velocity here means how fast the data come your way for processing, because this is very important. If you're analyzing workstations or your computing system is unable to process the data very quickly, then you will have accumulation, and that will actually make life very, very difficult, because analyzing the data is not really very easy as people. It's not a matter of just getting the average or the standard deviation. So there are a lot of other things that we can talk about, and also the variety. The variety of the data. You know, usually if you go to a supermarket again, you have food products, makeup products, cleaning products, maybe meats and things of this sort. So each one of those categories need to have a description of its own. So that takes us to you know, the types of data that we have. We have open data, which is generally generated by organizations, public organizations, governments, and things like that, schools, universities. And then we have the data that are interlinked with one another. And when I talk to you on WhatsApp, then there is a connection. So there is you and there is me, and we are actually connecting. Now, if we are connecting on a daily basis and we basically talk on a hourly basis for maybe 15 minutes, that is different in terms of description from someone who is talking with someone else maybe once a month. So, so social networks here can also describe the data that we need to collect to describe the types of relationships that we have. So what we have now is defining what's called the digital enterprise, and Mr. Hattan was actually has talked about it. This is now the established way of describing, and the leading organization or company in the world that actually the idea of Industry 4.0 came from Germany, and it was led by Siemens. And they coined the term 4.0, Industry 4.0. So this is the interesting line here. Our resources are finite. So what we have is, no matter how big it is or large it is still limited. It is finite because on the planet, our population is increasing. The population in a country is increasing. And at the same time, when something like COVID happens, we find that the resources become more and more scarce. So, so the resources are finite, and we are all required to do more with less because we are getting less. So how do we actually improve our lives with less? This is the question that we need to ask. And there is a great deal of answer that we can get from analyzing the data that we are collecting. So what I'm saying here is that it is impossible today to live without knowing, without collecting data. Any establishment, company, big or small, school, high school, university, research center, medical establishment, all need to collect data to analyze so that they know where they stand and where they want to go based on their objectives. So this is basically what we need to do. And this is what makes the resources that we have to be more sustainable. And if you look here at the definition of the smart city, by the way, I like this quote here. Our aim is not to have the most data. So it's not about, yeah, we need to collect data, but eventually it is how we unleash the greatest value from the data, how we understand our behavior or the behavior of the process from the data that we are collecting, and how do we use the data to create new opportunities. And I know that in the previous presentation, people did ask about, well, will AI and data and the digital transformation will replace people? Well, in essence, yes and no. And this is a challenge for all of us. If we cannot really keep at the forefront, we will miss, and we'll miss the opportunity, and we will suffer from that. This actually statement here was done by the president of the Emirates, Sheikh Maktoum, Ibn Al Maktoum. And I just love it very much. I was visiting there not too long ago, and I found that quote, and I felt that it is very important to use it. Now, what is a smart city? A smart city is part of this conglomeration that we call digital transformation or Industry 4.0. So smart city is an urban development, and some people were asking about construction. An urban development vision to integrate information and communication technology and the IoT, the Internet of Things, to secure and manage the city's assets and resources. And so this is very important. Now, in fact, there are some projects in Egypt now where they actually have smart cities, like I think I forgot the name. Shireen, it's across the street from or the highway from Shuruk, Medinti. Medinti now they have implemented in part, some aspects of the smart city. So, and by no means this is an ideal. This is still in the growing stage, and there are other places elsewhere, whether in Europe, in Saudi Arabia, or the US, where actually there is something called really smart city. So, as such, this is what we have. The digital transformation generates big data, and the big data means volume, velocity, variety. But there is one more aspect that we must pay attention to, which is governance. How do we protect ourselves and others from misuse of the data? And this is one of the questions that was actually presented to Mr. Hatan. We need cybersecurity, and cybersecurity is part of the governance, because I do not want to be in a place where everything about me is known, and about my private life. So because there is a danger of really sharing unnecessary information with the rest of the world. For example, my medical records, for example, anybody's medical record should not be shared with everybody in the world. It needs to be handled and shown only to your doctor or your hospital or whatever. And it has to have your permission given to it. So how do we protect? This is part of governance. What do we do with the data is a social responsibility that not only the government needs to pay attention to, but every other company needs to pay attention to, as well as ourselves. So because if you decided that you want to attack somebody, then you are open to being attacked by someone else. So we need to really see that. I am going to, I spoke about these three, and now I need to move into something very important, which is, now I have made the introduction. What do? We talk about processing the data in the sense of machine learning, تعلم الآلة, and artificial intelligence, which in this case it's not the real human intelligence or the God-given intelligence that we are bestowed with, but rather it is what we learn from the surrounding environment. So here, I talk first about machine learning. Machine learning basically is two kinds. There are more, but I will focus here on two things. One is called supervised learning, and the other is unsupervised. I start with the unsupervised because this is what every one of us has done when we were small babies. You get to learn about the different genders. You know about the mother, you know about the father, and they look actually kind of different in terms of shape and in terms of how they talk. So they do not know exactly what a mother is or what a father is, but they know that there is a mother and grandmother and al-khala and al-amma versus al-ab wal-gidd and al-am wal-khal, and so on and so forth. So this is one category of people, and this is another category of people. They share some things, but at the same time, they are not exactly the same. This is what we call clustering. And it does not require a great deal of knowledge, it just observations. And of course, now what I'm talking about here is purely mathematical description of the situation. And then we have what's called the supervised learning. And the supervised learning, we use it basically to classify things. In other words, if now this baby or this child sees a lady, then he or she will understand that this lady is not a man, but it is like his mother or grandmother. So he classifies or she classifies that human to be a mother or a father, and that's it. So classification is very important, but also we have a regression. Regression here means that, okay, that I have collected data. For example, we have been collecting data about the 100-meter runners in the Olympics for over 150 years. And when you collect the data, you find that the performance of the runner, whether it is a man or woman or the different age and so on and so forth, actually decreases, meaning that you are performing better as a runner. And so I get someone with certain characteristics, and then I ask, how do you think will actually this person perform in a run in the Olympics? So that is called regression. Prediction, you are predicting what could happen. Prediction does not mean that you're going to get it 100% right, but you say that this person is going to do a 95 performance with 5% error, and this is allowed. So when we talk about data analytics, we are not talking about 100% all the time. We're talking about great possibility that this something will happen with a bit of error, and we want to, using our mathematical techniques, to minimize the error that we are collecting, maybe by improving the algorithm or by improving the data. Now, I need to tell you something about the data here, because what happens, when we get data, most of the time the data is dirty. By dirty, I mean, for example, if you are doing a questionnaire and you're sending someone representing al-Hukuma, for example, and they are going to the census, okay? He goes to, an apartment, a flat, and then knocks on the door. Someone opens the door, someone does not open the door. So if they open the door, they can actually, he can find the father there, or maybe not. Then he starts talking. Maybe he was tired. It is 5 o'clock in the afternoon, and he has seen something like maybe 20, 30 different families before. So there is a possibility of doing an error. This is when data is collected by hand. But also when it comes to databases, you might actually, if the programmer who designed the database was not careful enough, then and all software actually is subject to problems. We know that. This is a fact for the past 50 years. So if you can actually describe, if you're looking for, let's say, an age or the year of birth, and instead of doing it 1999, you say it 1901, and that is a mistake. So in this case, you have actually altered the data, the original data. So you need to clean the data, and this is something that we must pay attention to. Now, this slide here talks about in a bit details about the different algorithms that we use. This is just a small set of algorithms that we use. Support vector machines, discriminant analysis Bayes. Some depend on the statistics, some depend on probability and a mix, and some depend on pure engineering. So this is always the case. Now, we always talk, when we talk about data analytics, we talk about pipelines, workflow pipeline. So you access the data, you pre-process the data, meaning you clean the data. Sometimes you also curate the data. For example, you get a number that you don't know exactly what it is, what it belongs to, or the metadata that describes it is not very clear. So you have to do this by hand. Most of the time you do a lot of things by hand. By hand here does not mean that you actually type it. But there are programs that you can use to clean the data for you so that you can use it. And by the way, when we talk about data and data cleaning, you could collect the data probably in a day, but to clean it, it might take you a month. And this is very common. So do not feel that, I collected the data for one day and you're having problems cleaning cleaning it up. No, this is normal, but you need to have some sort of a plan how you are going to clean the data and how you're going to curate the data. When we talk about machine learning, we have what's called the learning process. The learning process here means that first you have a set of data that you have collected, and you train your algorithm to really understand the data and create the ability to make a decision. Then you bring data that the algorithm has not seen, and at that time you test, validate the data that you have received after you have done the cleaning. So this is called the validation process, which is run on real time or real life data. So this is what we have here. I'm not going to spend too much time on this, but regression, this is, you get a bunch of points here, some bunch of data, and on the graph on the left, we see that we can actually describe the data here as a straight line. Of course, the blue dots here also tell you that there is error in collecting the data. Here we have only two variables, one the x-axis, the horizontal axis, and the vertical axis. On the picture or the diagram on the left, we have what's called multiple regression, which allows us to see more than one factor affecting the data. So for example, if we're looking at the runner, for example, maybe the runner is a man, or the runner is a woman, or maybe their food is this, or drinking is this, and so on and so forth. So we have multiple factors that go into the play. And also, this is how we describe clustering, classification, sorry. And you see that we have the green, blue, and red regions, but also there are some points, for example, in the red here, you see in the red region, you have green points and blue points, and these are errors. And the question is, your classification system need to minimize the errors that you have, and this is probably not the best way to cluster your data or to classify the data. Here we have another. This is a very famous example that has been done about 100 years ago or so, about 3 different kinds of flowers. And till this moment, we teach it to our students. Then we talk about what's called artificial intelligence. So now we also use AI and machine learning sometimes interchangeably. The two are based on one basic idea, which is how do we learn from the data? So you collect the data, you design the collection of the data, and you collect the data, and then you learn what you've done with the data to produce the data. Okay, so in this section, I talk about the AI specifically, because this is a very interesting thing. Back in 1948, 2 scientists talked about, they wanted to understand how the brain cells work. And the brain cell is a very complicated subject. But you see it on the left. This is an electron microscope picture, and on the right is basically a graphical representation where you have the nucleus, which has all the processing, and you have the synapse, and also the dendrites or dendrite. Which are, one is to capture the information, and the other is to present the information, the processed information, to the next cell. So this is biology, this is medicine, but engineers and mathematicians came with this idea. So you have on the left, you have P is your input, and F here is, you can think of it as the black box representing the nucleus. And so you give an input to the black box, and the black box does what it does, and it gives you an output A. In on the picture on the left, we have what's called bias. we add the bias, and the bias here is called B. So it is exactly the same thing, but now let's say that you are talking to me, and then you watch something on the TV that made you happy. That is B. Okay, so it affects the way you actually process the discussion that you and I have. So, and then we complicate things a bit more. So instead of having one input, we will have a number of different inputs, P1, P2, all the way to PR. And then we sum all that. And this is actually as real as you can think, because what happens here is that while you're sitting watching the TV, your children are actually making noise. Your wife or husband is telling you, you know, we need this or need that. So all these, you know, will come together with certain weights, and then you hear good news or bad news, and all of a sudden you have a different behavior that goes into the F, and F gives you the answer. And then we complicate things. Instead of having just one cell, a neuron cell, we will have, in this case, 3 neuron cells. And then you can actually make things even more complicated by saying, oh, I'm going to have a first layer that will understand something, and then we'll send it to a second layer to do something with it, and then send it to a third layer to do something. But if you see here, if you follow the P1, the top line, it goes into sigma. Sigma means add to the F1, which processes. It gives you an A1, and that takes you to A2, F2, and then A2, F3, and A3, and so on and so forth. Now, today, when we talk, and you might have learned or heard what we call deep learning. So here I have 3 layers. What do you think if we have hundreds, if not thousands of layers, all processing very basic information to come up with a final decision, which is the circle on the right? So here, this is the complexity. And we say, you know, subhanAllah, for our, you know, how God has given us the ability to actually make a decision, a simple decision. A baby to really go and eat an apple or a cucumber or something will process all these using all the layers that will enable him or her to actually extend their hand to grab the apple and eat it. So what we have here is, what do we need to really consider? And I'm closing my discussion here. Building a better machine learning model requires more data. I would say more and more data. Curating the data is extremely important. Curating meaning when you go to a museum, the word comes from museum usage. When you go to a museum, you have a statue or something and you don't know what it is, so you will find an expert writing a little card to tell you that this is King Amun or whatever the case is. And then how good your thing is the model that you are using to describe your data. Because, and eventually you need to also tell me, when you tell me, oh, I think we can do this. A good manager will say, fine, you tell me that you can do it, but tell me about the error. How much are you confident of your answer? This is the error analysis. And then once we do this, we are always improving our algorithms as we gain more and more accurate knowledge. And this is my closing slide. We need data science, analytics, digital transformation requires something called subject matter expert. So data analysts or data scientists, they are expert in processing the data, but they need to understand where the data is coming from, like it's coming from a petroleum site, for example, and I did work in petroleum industry. And then you need to be able to talk with someone who understands petroleum engineer or a mechanical engineer who is in charge of making a particular part, because they will be able to tell you when the part fails and when the part is acceptable, and so on and so forth. And of course, we need the data scientists who are able to implement the algorithms. But without powerful machines and better internet and better algorithms, there is no such thing as digital transformation. So digital transformation, and of course, Industry 4.0 really depend on these 4 building blocks, and this is what we need today. I thank you very much for your patience with me, and I think 5 minutes extra, so I apologize. So if you have any questions, I would be more than glad to answer.
Just a question. We have only 5 minutes. So one is telling you, please, doctor, don't forget the packages, the software.
Oh, okay. When it comes to processing the data, there are no really packages. There are programming languages. So you have, of course, Python. Python is very, very commonly used, and it is a general purpose language, but also has immense number of libraries that we use today. And there's also the language R, capital R, which comes from the statistical knowledge that we know today. It was developed in Bell Labs in America. And if you want to have visualizations, which I did not talk very much about visualization, you have Tableau, and also the 2 languages, R and Python, they do have visualization libraries that you can use. If you want to basically just visualize, then something like Tableau will do. There's something else that I did not speak with, maybe except in passing, which is graph theory or network science, meaning how people communicate with one another in social network setting. They require something like Network X, and also another program is called Gephi. I can write these things and send them to Dr. Shireen, and she can share it with you. So these are the programs that I personally use and my students, and I use them with the projects that I have.
Yes, doctor, and for anyone who wants, there are many tools, and Gartner makes as well classification. Okay. And Mr. Mohammed Shams, it will be point number 29 in our glossary, which we will share later. So thank you for the question. Thank you, doctor. It's really impressive. I love the way you explained the deep learning and how it's very complex for our people, normal people, to understand. And how can software be such amazing and very fast to do deep learning, and lots of applications in deep learning in cars and Tesla cars and many areas which we have.
Yes, in fact, I need to tell you something also that we need to be aware of. When we collect the data and we put them into processing does not necessarily take a second or 2. I have some analytics that I perform on some of my problems. They can take as long as a week or 10 days to process. So this is okay. There's absolutely nothing wrong with that. So, everything has a cost. And in this case, to be able to make a decision that management would be able to use to change the direction of the company, waiting for a week is okay.
Okay. So, doctor, because people write for you, appreciate it, doctor. We enjoyed it so much. So I think many people are happy about your session, doctor, and we will organize more sessions with the doctor. So and as well, we have list of softwares which we can share, like as the doctor mentioned.
Yeah, Power BI, of course, with the Microsoft,
as I
of
mentioned,
course.
29 the glossaries.
Yeah.
Power BI, you have Tableau. Can we move forward? We have many images, and we have the link for all of them in the glossary, which we will share. So move to next page, please. Yes, we have many tools. Okay, as the doctor mentioned, and it includes Oracle, it includes IBM, it includes SAP, it includes lots of tools like SES. So we will share it with links. So now we need to